Hi there, and welcome to this lesson on Pure Mathematics 2. In this lesson, we're on Chapter 3, 3.4, and we'll be looking at how you solve equations using logarithms to help you. Now, logarithms are particularly useful when we want to solve equations where the power is a variable. So, for example, if you had the equation 3 to the power of x equals 20, the power there is a variable x, and it's x we're trying to find. In this case, to 3 decimal places they've asked us to. And the method is, we're going to take the log of both sides to any base, and then move on from there. Now, I think I'll let you see if you can make sense of this yourself. So pause the video, have a go, and then come back to me when you're ready. Okay, let's have a look. So that's the equation, 3 to the power of x equals 20. If ever you have an equation and the power is a variable, then basically the method is nearly always the same. We're going to be using logarithms. We'll take the logarithm of the left-hand side, the logarithm of the right-hand side. It could be to any base. The convention is if you just write down log, it means log to the base 10. And log on most calculators means log to the base 10. But this would work using any base. The next thing to do is to bring this x down using the rule with powers. So x log 3 is equal to log 20. And then we can divide by log 3. And that'll give us the answer. So x is equal to log 20 divided by log 3. That you put into your calculator and write down the answer, in this case to 3 decimal places. X equals 2.727. Now, that's the standard method for solving this equation. Because modern calculators allow you to put in any base you want, there is another method. So I'll show you a second way of thinking about it. Instead of doing what we did, because this power here is 3 to the power of something, we could choose to use log to the base 3. So take log to the base 3 of both sides, and that'll give us log to the base 3 of 3 to the x is equal to log to the base 3 of 20. And the reason for doing that is log to the base 3 and 3 to the power of their inverse functions. And as we said before, because they're inverse functions to each other, they just cancel each other out. So the left hand simplifies to x. And on the right hand side, we've got log to the base 3 of 20. Again, that you would just look upon your calculator. So you do log, you choose the base to be 3, put in 20, gives you the same answer as before. Either method is fine. I think I'll probably be using this first method most because it's the method I'm most familiar with myself. Okay, example 2. Solve the equation 2 to the power of 3x minus 1 is equal to 5, this time to 3 decimal places. And again, the issue here is we've got an equation where the power is a variable. The power is x. To solve it, we'll take logs of both sides and move on from there. Now, I'll let you have a go at doing it yourself. So pause the video, have a go, and come back to me when you're ready. Okay, let's have a look. So as I said, we'll take the log of both sides. This is log to the base 10 because that's what I'll be using on my calculator, but any base would work. As before, we're going to use the rule of powers to bring the 3x minus 1 down to the front and multiply by it. And then as before, we'll just take the log 2 to the other side and divide by it. That gives us 3x minus 1 is equal to log 5 divided by log 2. This we just do on the calculator. Log 5 divided by log 2 will give us that. And we've now just got a simple linear equation that we can solve. So x will equal that, which is 1.107 to 3 decimal places. Okay, example 3 looks a little bit more complicated because it is. We've got 4 to the power of 2x here. We've got 4 to the power of x here. Now, I'll get you started on this because it's quite tricky to see what's going on and what the best approach is if you haven't seen this before. Keep an eye out for this, where you have 2x or 2y, 2 times a variable, but then in the other occasion, you just have 1 times by the variable. Now, 4 to the power of 2x, that is the same thing as 4 to the power of x all squared, just using the normal rule for powers. So 4 to the power of 2x is 4 to the power of x squared. Now, what we've got now is a quadratic. We've got 4 to the x squared minus 17 times 4 to the x plus 16 equals 0. You could leave it like that, but it does make it a little bit easier if we use a substitution. So instead of writing 4 to the x, I'm going to use the substitution y is 4 to the x. Doing that makes it look like a completely normal quadratic. We're going to solve that quadratic. When we solve that quadratic, we'll get two possible solutions. Both of those solutions will involve an exponential with an unknown power. And at that point, you'll have to use logarithms to get the final answer for both solutions. Now, quite a lot going on here, but I'll let you have a go at finishing this question off. So pause the video, have a go, and then come back to me when you're ready. Okay, let's have a look. The first part is straightforward enough. We've just got a quadratic we need to solve. That one does factorize into two brackets, which gives us two possible solutions, y equals 16 or y equals 1. Whenever you use a substitution, at some point you're going to have to undo that substitution, and this is the point. So we'll now go back to saying, well, we introduced y, but y is 4 to the x. So we've got two solutions, either 4 to the power of x is 16, or 4 to the power of x is equal to 1. Now, both of these answers you could write down by inspection, but I'll show you the formal method for the first one, just so you get used to seeing it. So the first possibility is 4 to the power of x equals 16. If the power is an unknown, we take log of both sides. So log of 4 to the x is equal to log of 16. The power then comes down to the front. We get x log 4 is equal to log 16. Then we divide through by log 4, which gives us x equals log 16 over log 4. That you put in the calculator, you'll get x equals 2 for the answer. We could have got that straight away. If we go back to this equation, it's saying 4 to the power of something is 16. Well, 4 squared is 16. So it is obvious in this case that x equals 2. But that method would work when it's far less obvious. This one we will do quickly. So 4 to the power of something equals 1 for the answer. Well, 4 to the power of 0 is 1 for the answer. Anything to the power of 0 is 1. So in that case, x must equal 0. Therefore, the solutions to the equation are x equals 2 and x equals 0. Example 4, again, we've got a complicated looking equation with two powers where both of the powers involves a function of x, 2x minus 1 here and 3 minus x there. Now, I'll get you started. So 3 to the power of 2x minus 1 equals 6 to the power of 3 minus x. We are going to take logs of both sides. And then we're going to split these things up using the normal rules and try and make progress. I'll let you have a go and see if you can make sense of how we move forwards on this question. So pause the video, have a go yourself, and then come back to me when you're ready. Okay, let's have a look. So the first thing we're going to do is the normal thing with the power. We'll bring the power down to the front, which will give us 2x minus 1 times log 3. Bringing this power down to the front gives us 3 minus x times log 6. And then we will multiply the brackets, which gives us 2x log 3 minus log 3 is equal to 3 log 6 minus x log 6. This next step isn't completely intuitively obvious, but what we're going to do is we're going to collect the terms which have got x on the front on one side and collect the other terms which are just numerical on the other side. So that'll give us 2x log 3 plus x log 6 is equal to 3 log 6 plus log 3. And the reason for doing that is we can then factorize the left-hand side, which gives us x into 2 log 3 plus log 6 is equal to 3 log 6 plus log 3. And now we can divide by the whole of this bracket, which does give us x. So x is equal to all of this divided by all of that. And the whole thing you can just put into your calculator. And when you do that, you'll get x equals 1.623 to 3 decimal places. Okay, that gets us to the end of this lesson. If you've got a textbook, then turn to page 58 and have a go at exercise 3D. Thanks very much for listening, and cheerio.